Okay, so thank you, everybody. I'll just give you a little bit more information about myself because I have probably a slightly unusual mix, and that I'm a bit of in English we might say jack of all trades, master of none. So I have a kind of mixed background in that my first degree was biochemistry, and then I ended up doing nutrition at the London School as a master's, having determined that I actually I loved the science of a lot of things in laboratory, but I actually hate doing lab work. And I started a PhD which was going to be pure lab work and went, ugh, no. But I always wanted to combine this kind of lab side of things and the sort of basic science to make sure that what we do in the field with community-based or clinical interventions has a sound basis in basic science and an understanding of the mechanisms by which these interventions might be working. So that's the kind of background I was coming from. So during my master's, I knew I wanted to do research and I knew I wanted to work overseas. And so I developed my PhD proposal, which was a clinical trial, as Professor Chiara already said, of vitamin A supplements in primigravid pregnant women in Ghana. And this was part of a really big trial that was ongoing, or was just starting at the school, which had randomized 230,000 women in the central region of around Kintampo in Ghana to weekly vitamin A or placebo, and their outcome was all-cause mortality. And so I set up a small sub-study in an area before the trial intervened in that area, looking at mechanisms of effects on immunity to malaria in pregnancy, because vitamin A has lots of potential immune stimulant effects. So that was the start of my sort of interest. And then after that, before I'd actually finished my PhD, I got a job at the London School as a research fellow, which is kind of the same as assistant professor, teaching nutrition and metabolism and starting new research on anemia, genetics and nutrition and the interactions between them and infection. So I was looking at malaria-associated anemia in Gambian children. And then that led on to hypotheses in sickle cell disease, which is a genetic disease that affects the blood and is common in any population that has a high exposure to malaria. Because if you are born with the heterozygous condition, then as a child you're less likely to die from malaria. But if you have, it's a recessive disease, if you have both disease genes, then you have severe disease, which has lots of negative health effects and high risk of mortality. And so I was looking at how other genes co-inherited with sickle cell disease and nutrition might impact severity of the disease. And then after 7 years, where I lived and worked in Tanzania. So I lived in Tanzania for 7 years, I lived in Ghana for 2 years, and I lived in the Gambia on-off for a year. I then moved to Japan. And now I've started some new research on nutrition and TB, which I'll talk about a bit tomorrow. So this morning's session is a bit of a sort of general intro. So some of this will be very familiar to those of you with lots of nutrition background, and less familiar to others. So I ask for your patience and understanding for those that it's all very familiar. So we talk a bit about basics of macro and micronutrients. And we're going to talk about how do you assess nutritional status, particularly in children. And we're going to talk about the differences between acute and chronic malnutrition. And then we're going to talk a bit more about stunting, and what are the causes and effects and why we should care about stunting from a global health perspective. A very little bit about treatment and management of acute malnutrition. And then I want us to remember that malnutrition just means poor or bad nutrition. So malnutrition technically means both under and over nutrition. So we'll talk a little bit about that as well. So very much back to basics. Remember macronutrients, we've got our carbohydrates, protein and fats. So we're going to think very briefly about what kind of foods provide these for our macronutrients. And we'll talk a little bit about what are the effects of insufficient or excess intakes. And then micronutrients, just a reminder that these consist of vitamins and minerals, and that the vitamins can be water-soluble or fat-soluble. And then we'll talk briefly about the difference between type 1 and type 2 nutrients, which is quite an important, useful concept. So in nutrition, we often talk about different nutrients, but we have to remember that people eat food, not nutrients. So if we're thinking about those nutrients, I'm sure most of you are aware, so carbohydrates are our main energy source, or should be. And then fats, again, are energy source and energy store. But they also have lots of important functions. They're not just there to store energy. They have lots of bioactive compounds included in fats. They're essential for cell membranes. When I was studying sickle cell disease, the physiology of the red cell membrane, which is actually very simple, but is actually very important and makes a big difference to various health outcomes, the exact balance of fatty acids, etc., in those cell membranes. And you've also got your steroid hormones that are from fats. Proteins. We know that we need proteins for growth. They're the building blocks of the body, and also all the enzymes that facilitate or catalyze biological reactions are made up of proteins. And proteins, if you remember, are from amino acids. And amino acids, you have essential and non-essential amino acids. So could anyone just put your hand up if all of this is very unfamiliar? So everyone is kind of familiar with essential, non-essential amino acids, carbohydrates, fats. Okay, perfect. So when we think about carbohydrates, we generally think about our staple foods, and that something like 40% of our energy should come from our staple foods and carbohydrates. And so I've got some pictures here of maize, rice, wheat. So the important thing to remember, though, is that staple foods are not just a source of carbohydrates. They also contain quite a lot of protein. So for adults in particular, a diet which has sufficient energy that contains one or more staple foods will also provide enough protein. So it's actually, and people tend to forget that. The only problem is that you need a combination of different foods, and ideally you need protein sources as well. But for an adult, you can actually get enough protein from the staple foods as long as you eat a combination and you're getting enough energy. The only one that's an exception of this is cassava. So in some areas where the diet is based purely on cassava, this is where problems can arise because it has the lowest protein content of any staple food. And then the reason why you need a combination is that some different staples are relatively deficient in different amino acids. So maize is relatively deficient in tryptophan, which is not actually a purely essential amino acid, but it's also has low bioavailable niacin that I'll talk about in a minute a bit more. Whereas rice, if I get this right, rice is relatively deficient in lysine, and then wheat is relatively deficient in one of the other amino acids. So hence, if you have a combination, as an adult, you should be fine. So again, when we think of protein sources, we tend to think of meat or fish. But of course, actually, all those meat and fish also contain lots of fats. And in the case of oily fish, then that can be the sort of what we call the good fats, those N3 fatty acids that we think generally have beneficial effects. And they also contain some of the essential fatty acids, such as docosahexaenoic acid, or DHA. And then you may have heard about saturated fat and trans-saturated fat. So saturated fats are the ones that traditionally we've thought particularly increase risk of cardiovascular disease. That thinking is a little bit outdated, perhaps. And what might be more important is these trans-saturated fats. So it's the way that the fats are saturated. So nowadays in Europe, and I'm not sure in the States, but in Europe, products have to label how much trans fats they contain. And they were particularly high in fats which have been hydrogenated. So things like you take a vegetable oil and you make it into a solid. And you do that by passing hydrogen gas through at high pressure. And that creates these high trans fats. But the other source of trans-saturated fats is from ruminants. So meat from cows in particular. So beef naturally has trans fats in it. So that might be one of the reasons why high meat diets, aside from just saturated fats, and high beef diets are not so good. And then, of course, carbohydrates and fats combined. Baked goods, cakes, biscuits, very high in fat and sugar. And then just to remember that nowadays there's even some foods that you could say are rich sources of all three, where you have these yogurt products that actually have grains in them as well, which is actually one of my favorite things. Okay, so micronutrients, we're not going to cover all of these at all, but they're just here as a reference list. And then the ones in red I've highlighted are ones that have sort of public health relevance. So you got your B vitamins, and then they have these weird numbers, which are because when vitamins were first being discovered, there were lots of things that were thought to be vitamins that turned out not to be. So there was at one stage a B4 and a B5, but they turned out not to be vitamins. So thiamine is associated with rice-based diets. And then we've not really got time to talk about it. Beriberi is the deficiency disorder. And then niacin we're going to talk about a little bit today, which is also known as nicotinic acid, and you get it from maize-based diets. Folic acid, we'll talk a little bit about in relation to anemia. And then vitamin A we will talk more about because of the impact it has on immune functions. And we'll talk a little bit about vitamin D as well, and because there's new evidence about its importance in a whole range of diseases, but also those impacting on infection and immunity. So a little bit about pellagra. So pellagra used to be very common, including in the USA, in the southern states, largely in black populations, poor black populations who were eating maize-based diets. And of course, maize came from South America, as in fact did lots of the foods that we now think of as global foods. Tomatoes, potatoes, maize, all came from South America. So until the 1600s were unknown in the rest of the world. But maize, traditionally eaten and processed in South America, was treated. So when they ground the maize, they would treat it with lime water, which is an alkaline solution. And they did that because it releases the niacin that's included, so the vitamin B3. Because otherwise the niacin is quite biounavailable. And niacin is used to make tryptophan, an amino acid. So maize is both low in niacin and tryptophan. And that means that if you don't treat it, you can get this condition called pellagra, especially if you don't have a mixed diet with other sources. So the symptoms can be quite wide-ranging, and they include depression, insomnia, dementia, and a sort of general malaise. And this is, from the history of nutrition perspective, there's some interesting pieces about from history side of things, and how long it took us for many of the deficiency disorders to be understood as being nutritional in origin. And because this affected poor black populations, it affects women, and we still don't quite understand why, much more than men, and that it had these rather sort of general symptoms, depression, dementia, insomnia, which at the time, especially when they were in women, was all ascribed to something called hysteria, and was thought to be nothing to do with, nutrition or to have a sort of a medical basis. It was just because you're hysterical women. And then these were poor black hysterical women, so not so much interest. So there was lots of evidence right in front of the researchers' faces to say, this is nutritional. But we think that as scientists we're objective. We are not. We try to be, but we are often not. And this is a great example in history of how people's beliefs and preconceptions affected how they saw the evidence in front of them. And it took a long time for it to be accepted that this is a nutritional disorder. So for a long time, pellagra was kind of forgotten about and thought, oh, this doesn't happen anymore. But in fact, it can do, and not so much anymore, but a few years ago, with a long-term refugee situation in Angola, a colleague of mine showed that actually it was still quite a major issue. And it's a bit harder to detect, especially at slightly milder levels than was traditionally seen, because the first signs are insomnia and slight mental disturbance. And when you're dealing with a refugee population who've escaped from years of war, well, how much of that is just the environment and how much of that is nutritional? So on the left here are pictures of the real classic skin symptoms, and that's called Casal's necklace. But you don't normally see symptoms that obvious. So these are pictures of real cases. And you'll see that, so where the skin is exposed, you get this atopic dermatitis, but it's quite non-specific. So it tends to be around the neck still, so you can see it here. And then the butterfly face, again, that's not from one of the patients in Angola. Again, you rarely see something as obvious as that. So there's these different stages in deficiency, and I'm using niacin as a good example. So micronutrients for which you have stores, you have a sort of optimal status where you have full stores and you have enough for every function. And then your stores can become depleted. And then after that is when you might get lowered circulating levels of the active form of the micronutrient. And then you might get functional impairment. For example, lots of the B vitamins are required because they act as coenzymes. So they're required to make enzymes work properly, particularly in energy metabolism. And then finally, only at the very end do you often get the clinical deficiency of signs and symptoms specific. So what you get is this triangle where when you see a few cases of clinical pellagra, for example, you know that there's going to be a much larger proportion with inadequate stores and biochemical deficiency, and then a much larger population at risk. So things like pellagra or beriberi or xerophthalmia for vitamin A deficiency, as soon as you find just 1 or 2 cases, you know you have a problem, because they're the tip of the iceberg, as it were, the top of the triangle. You have a large proportion who already have low stores or biochemical deficiency and are larger at risk. And there can be negative health impacts in these conditions too. So this was the case of pellagra and niacin in Angola. Oops. So there was 29% with biochemical deficiency versus just 0.3% with actual clinical signs and symptoms. So those biochemical deficiency population, they're the ones who are often suffering from mild insomnia, slight depression, malaise, which is so non-specific in that environment. You're not going to know that it's being contributed to by poor nutrition. So we'll talk a little bit more about assessment of nutritional status and some general principles for doing it. So it can be indirect or direct. So the indirect, which you would often use in this kind of refugee or emergency type setting, would be measuring what people eat and then looking at the risk of deficiencies. So you know that if the diet is very limited and is all maize and with few other protein or micronutrient sources, they're going to be at risk of various deficiencies. And then the direct would be actually measuring clinical signs or biochemical measurements. But as that becomes more difficult, and you've either got to take blood samples or do clinical exams on lots of people. So again, the indirect, look at the food availability measures. So again, this is what Andy did in Angola. So he looked at the food basket monitoring because they knew what people were being given, and you analyse, is that going to provide adequate nutrition? And often what's being provided by UN agencies is not sufficient by itself. It's often just oil and rice or oil and a carbohydrate. But you could also look at other indicators. So you know that if you've got high levels of measles, you're likely to have, well, as well as low vaccination or low vaccination deficiency, vitamin A deficiency. And if you see high rates of stunting, that we'll talk about a bit more in a bit, you suspect that zinc deficiency might be a common problem. So direct assessment, you've got clinical signs versus symptoms. And the problem is that often these are not very specific. So again, things like insomnia, depression, malaise for niacin, that's not at all specific. Okay. So that's just whizzing through some basic principles. Then just to touch on the different minerals, and some of which we're going to talk about. So iron, we're going to talk more about during this week. Iron, I'm sure you all know, we need to make red blood cells, and therefore iron deficiency, one of the common symptoms is anemia, but that happens once you've become really iron deficient. It's also required for cognitive development in children and also required for effective immune functions. Calcium, I'm sure you all know, we require it for proper bone development, also teeth, also neurotransmission. And then sodium, we're not really going to talk about here this week, but too much sodium, too much salt is related to high blood pressure. And then you've got your trace elements, so those ones that are needed in very small amounts. So we're going to talk about zinc, and then also a little bit about iodine. So this idea of the type 1 versus type 2 nutrients. So most things are type 1 nutrients, so that they have a specific deficiency disorder, even when sometimes it could be quite difficult to see because the signs and symptoms might not be very specific, but there will be a physiological, clear effect on certain processes. So you can measure low enzyme function, for example, in some of the B vitamins. So the main thing is with these is that you have a specific deficiency disorder, but growth will continue normally. But type 2 nutrients, what you get is this growth faltering, but there's no specific deficiency disorder. So zinc is the classic type 2 nutrient, because zinc deficiency, there's not enough zinc. It's required for so many processes that what happens is you'll just slow your growth right down to match your requirements. And the same is true for your essential amino acids. And it's also because there's no storage site. It's not like iron, which you can store in quite large amounts in the liver. There is no place to store zinc, really. And you need to maintain a certain circulating level. So these things are fundamental to tissue structure and function. And the circulating levels are maintained even when you're deficient. So it makes it very hard to measure status. So as I said, malnutrition means poor nutrition. So you've got both under and over nutrition. And then we're going to talk about undernutrition as being acute and chronic. So acute obviously means you've experienced not enough energy and protein over a relatively short period of time. And then you lose a lot of weight rapidly and become what we might call wasted. Whereas chronic is where there's not enough protein and energy over a prolonged period of time. And if you're a child, then you reduce your rate of growth and become stunted. So how do we assess nutritional status? So in children, what we do is we take a reference population, which we think are a group of children who are growing optimally. Now, that's perhaps easier to say than to do, but you take generally a population of healthy children from sort of probably middle class sort of families, and you measure how that healthy population grow, and that's the reference population. And then you compare your particular child to where that child's growth is in relation to the reference. And we do that in different ways. So we can look at either their height for age, which will tell us if they are stunted or not, because you know that at age 2, the mean of a normal population, the child would be here. So if this is our reference population, you'll get this normal distribution of growth. So if this was all children in your reference population at age 2, you'll have the mean here, and the mean and the median will be the same because it should be a nice normal distribution. And then these are your standard deviations from the mean. So if you think back to your basic statistics, you should be familiar with this concept. that by the time you move 2 standard deviations away, then by chance you would expect only 2.1% of the population to have a height within this range here. And if it's less than -3, it's only 0.1% of the population. So what we do is we take this kind of Z-score cutoff, which is the number of standard deviations the child's measurement is from your population mean. And so you get these charts produced by WHO where you can't see it so well, but the green line here is 0. So that's your reference population median. So this is for boys. Ooh, you really can't see it very well on there. Yeah. So this is for 1 year of age. So the reference median would be here. So anything within these 2 standard deviations would be within the normal expected population range. And then here to here is outside. So this is -2 to -3. And then anything here is less than -3. So for stunting, we look at the height for age as a Z-score compared to the reference population. If we want to look at the acute malnutrition, we look at the weight for height for age Z-score, because you want to know in relation to their height how much body mass do they have. But what a lot of people have used in the past is weight for age, partly because if you're doing a big community survey, it's simpler, because then all you have to do is get an age and a weight, and you don't have to carry around a stadiometer to measure height properly. Or in children under 2, they can't stand up, you have to measure length, so then you need a length board. And it's actually harder than you think to get accurate heights and lengths. You really need to train your field workers well and make them do many repeat measurements until they're getting within a very small margin of error, because you only need to be a little bit out and your Z-score can be quite wrong. So we don't encourage using weight for age, because that's going to be like a combination, because it's kind of measuring both underweight, wasting and stunting, because if your child is also stunted because they haven't grown as much, then when you look at weight for age, it's going to look like they're more wasted than they actually are, because they're not as tall as you expect them to be. I have more slides, so this will become more obvious. And then the other thing we do in children under 5 is mid-upper arm circumference. So there's very simple tape which UNICEF provide free, which is colour-coded. So mid-upper arm just here, and a measurement less than 11.5 centimetres means that they have severe acute malnutrition, and if it's 11.5 to 12.5, it's moderate. And that seems to work in all children up to 5, from 6 months to 5 years of age. And of course, that's much simpler and much quicker. And you don't need an accurate age, because the other problem in these kind of surveys is getting accurate ages. Let me just say a little word about the reference, what reference population is used. So there's a link here which tells you about how these new reference population data were generated. So the WHO data set was replaced in 2006, I think, with a new data set which took children from, I think, 6 different countries: Brazil, Ghana, Norway, Oman, I forget the others. It was 6 countries, and they were all breastfed. And that's really important because the old data was using American children who were all bottle fed in the 70s. And children who are bottle fed grow faster. It doesn't necessarily mean it's better, but they tend to grow faster. So it wasn't a good comparison. And obviously they were nearly all white Caucasian children. So this is a much better data set. So if you see data that talks about compared to NCHS, which is the old American data, that shouldn't really be used anymore. You should always use the WHO reference population. Okay, so this is just sort of restating what we've said. So for wasting, which is your acute malnutrition, you can divide it into moderate and severe. So based on those Z scores, so moderate is between -2 and -3, and severe is less than -3. And this can be either weight for height Z score, or in children under 2, it's weight for length Z score, because you're measuring a length on a length board. And for older children, it's a BMI Z score. So you still calculate a body mass index, which perhaps I haven't shown yet, I will. But you need to do it as an per age Z score, because of course BMI changes with age until you're an adult. And then stunting, same cutoffs, but with height for age. And then overweight is the same cutoffs, but at the other end. So more than 2 Z scores. Or for an adult, your body mass index of more than 25 is overweight. So your body mass index, did I have it in this previous one? Yeah, body mass index is your weight in kilos divided by height in meters squared. Hopefully most of you are familiar with BMI. So again, the important thing to remember is that what you have in a lot of situations is children who are both. Because of course, a lot of the time you won't see much acute malnutrition until something happens. So there's a bad harvest, there's a refugee, there's conflict, internal displacement. When in a population that are already marginal, then something happens. And now you've got children who are already stunted, and now you have even not enough food to support that rate of growth, and you can have wasted and stunted children. So on a sort of population basis, this kind of WHO suggests that if you do sort of representative surveys and then you judge how severe the problem is in your country or your region, depending on the prevalence of stunting and wasting. So anything more than 5% of wasting, this is all in children under 5. So at the moment, nearly all the focus is on children under 5. I think we should be focusing on more than just children under 5, but from a sort of public health perspective, it's pretty much all on those children at the moment, partly because they are most at risk, and there's a lot of them, and they're the easy age group to target. But I do have an issue that older children and adults, when they are reaching medical health facilities, malnutrition is ignored as if it doesn't exist in older children. Of course, it does. So I will talk a little bit about that tomorrow in relation to TB. So one of the important things about stunting is that it's a population indicator. So if you have a child who has a Z score of weight for height of -3, that means something for that child. That child is acutely malnourished and needs treatment. For stunting, especially if it's an older child, it doesn't really mean very much for that individual child. It doesn't mean that you have to intervene and give them lots of extra food right now, because you'll probably just make them fat. It's more important on a population basis, which we'll talk about a bit more. So as we've said, stunting is chronic, and it's normally associated with marginal nutrient deficiencies of many things. So it's not just not getting quite enough protein and energy. Those diets will also be marginal in most micronutrients. And stunting, in a way, is an attempt by the body to adapt to those lower intakes. So it grows within its means. But that means that that child is unlikely to be reaching their maximum potential. And on a population basis, that can have a big impact. So obviously the countries in red are the ones that still have the highest prevalence of stunting. And what's interesting is you see in South America, let's say 20 years ago, a lot of these countries would also have been orange and red. And so they have actually made big improvements.
Which year?
This year is, it should be on here. I think this was 2013. I can check. It's relatively recent. So why do we care about stunting? So on a population basis, that we know that a high prevalence of stunting is associated with increased risk of child mortality. So in populations with a lot of stunting, those same populations will have higher child mortality, and mainly from infections. We also know that it's going to be associated with reduced cognitive development on a population basis. As I said, children who are not growing to their potential, that's going to affect their brain development as well as their physical stature. And your brain development requires a balance and optimum micronutrients, which they're probably not getting either. And then it's also been shown that shorter adults have decreased physical work capacity as well. So in environments where people are having to work physically very hard to earn their money, this can also impact their long-term earning potential. It also impacts their earning potential if they haven't reached their cognitive maximum as well. And then increasingly important, and this is what has got many countries really worried now, is the fact that people who are stunted as children, as the nutrition transition is happening and more calories, cheap calories, are available, as an adult, they're more likely to become obese and to have sort of metabolic syndrome. So stunted children grow into short adults who now may not be doing lots of physical work. You have cheap calories available, and particularly in South Asian populations tend to put on central obesity, and that's associated with metabolic syndrome, risk of diabetes, cardiovascular disease, etc. And then also stunted women are going to have, small women are going to have higher risks of problems during childbirth, and they are also more likely to have smaller children. So there's intergenerational effects. And unfortunately, we don't have time to talk about this, but maybe some of you might have heard about epigenetics. And that is now the mechanism by which we understand that these intergenerational effects can be propagated. So the other thing that's increasingly being realized, as I said, is that stunting is happening in a milieu of environmental issues. It's not just about food. So this was a model that was developed to think about how the nutrition status interacts with the environment at the home to impact on cognitive development and cognitive development. So if a child has perhaps slightly inadequate protein, energy, micronutrient intake, that's going to affect their physical activity because they've got to put all their energy into growing and they haven't got energy to waste running around playing. But we learn by playing and interacting with the environment. So it's not just that direct effect of the nutrients, but in children who do not play, who are not stimulated, who are not running around, they're not going to develop as well. And this also includes their physical growth. And this affects how they interact with their parents too. And in families where they're obviously poor, if they're getting marginal intakes, the parents may also have low education, they may be working very hard, they may never be at home. So there's less interaction. And all these things impact on the motor development, which means ability, fine movements, cognitive and social emotional development. And there was a very nice study quite some time ago by a woman called Sally Grantham McGregor, who's done lots of work in this area. And she did a trial that actually showed that it was 2 arms intervention. One was a nutritional support for the child, and one was a sort of family-based intervention about increasing play and time and stimulating the children. And the play interaction actually improved growth as much as the food intervention. And the two combined grew the most. And that study hasn't been replicated again, partly because it hasn't been done well enough in enough children in the same thing. But that just shows that you need the stimulation as well. So intergenerational effects, as I said, we're not going to talk too much about the biology and epigenetics because we don't have time, but to just understand how this cycle reinforces itself. So if you start with a neonate, you might have low birth weight or small for gestational children. So they're already small and their metabolism is already altered. So they might be hyperinsulinemic. And then they get, during weaning, and you get to 2 years. So in most populations, the mean birth weight, or the mean weight for height or length, is about minus 0.5 Z-scores. So in a lot of these low middle income countries, it's about -5, the mean. But by the time you get to 2 years, the mean is often dropped to -1 or even -2, because this is where a lot of the stunting is happening. And that's because this is the period when children start to be exposed to lots of infections. Their immune systems are not mature when they're born, so they're at increased risk. And then you may have poor wash, so water and sanitation, hygiene, so high risk of infections and repeated infections. And then if they're not practicing exclusive breastfeeding, I'll talk a bit more about that, they increase the risk of exposure to infections. Breastfeeding provides everything a child needs to grow properly, including things that stimulate the immune system. So there's a whole bunch of things here that can interact and affect on the risk of stunting. And then what can happen is that later on, you might have a diet adequate in nutrients with excess calories. And then that can lead to these later risk of being overweight. And then here, stunted children tend to do less well in school and less cognitive performance, it's very hard to show how much of that is really due to the biology and how much is confounding because of this environment. So it's the environment that causes stunting, that causes all of these effects. But then you have puberty, and there's a growth spurt in puberty. So we always used to think that if stunting had happened here, it was pretty much too late to do very much about it. But it's increasingly, we think, possible to intervene in puberty. But you do have to be a bit careful that if you provide a lot more energy in puberty, again, do populations put it into producing fat or increasing their linear growth? So that's still being researched a bit, but we think we shouldn't forget about puberty. And then, as we said, particularly women who were stunted as children are going to be small as adults and are more likely to have low birth weight children, and who are also programmed to potentially to be smaller. So I'll let you look at that in more detail later. It hasn't liked some of the things on this slide. So this, again, I'll let you look at in your own time. But this is a very good conceptual framework for understanding the context, cause, and consequences of stunting. So that context is very important. So you've got political economy, health and healthcare, education, society and culture, agriculture and food systems, water, sanitation, environment. So these are the context that affect stunting, which is why when we talk about interventions to reduce stunting, just providing more food is potentially not going to help that much, because there's this whole range of things. And this is why countries like the sort of countries that become middle income, for example, in Latin America, their stunting rates have gone down because all of these things have improved. So again, the effects of stunting may depend on context. So this is children in India, and this is their height for age Z-score. And this was a rather crude test about their reading ability. So there's potentially lots of problems around that test. But you could see that there's this steep line between the more stunted they are, the worse they perform on this test. And this is two different age groups. So it's steeper for one age group. But these high income kids, there's really no association. And that's probably because the causes of stunting in this population are different. So causes of malnutrition, so it's not just food, it's infection. So we're more and more looking towards infection as being one of the critical factors. And this is from an old study which followed up a group of children in Guatemala in incredible detail. And this is probably the most detailed study that's ever been done. And here this shows the growth of just one child. And this is where they're born. And then this is the reference population growth curve. So this is where you would hope they would be. And you can see that when they're born, they're a little bit below, but not too much. And quite quickly, they've caught up to where they should be. But then, they're doing well, and then, oh, here we are around, I think this is around 6 months, 9 months, this starts to happen. So this is this individual child's growth, weight gain. And all these events here are infections. So here they had I think this is a upper respiratory tract infection. Here's diarrhea, 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 diarrhea. So you see the first infections, just a few, and then they become more and more frequent. And then here, this is where they actually took blood samples and were showing that the blood and stool samples contained bacteria that you don't want there in the stool. and inflammation. And again, you can see here until it's just becoming more and more frequent. So this is why, these frequent infections. So you have this cycle where malnutrition depresses your immune system so it doesn't work as well. You get that first infection. Infection means that you lose appetite, you're losing nutrients, and then it becomes a cycle down. So when to intervene? So there's been a recent big push called the first 1,000 days. And one of the reasons for pushing that we need to intervene in the first 1,000 days of life, which means from conception to 1,000 days of age. And because partly to try and make really governments and people do something about it, saying it's irreversible. So there's been this big 1,000 Days initiative, which has produced lots of actions and programs, which is very important. But I just want to show some data from my old group in the Gambia that I used to work with, which has followed up in detail the growth of populations for the last 50 years in 3 villages. And this one is boys and this one is girls. And every little tiny dot on here is a single measurement. And then you've got the sort of mean shown as the lines. So you can see that here is 18. But here the boys in particular are still growing. So in the Gambia, again, you get the same pattern. Here is 0 Z-score. So they're born a bit below, and then they drop right down in this early life. But then they do increase a bit, and then sort of sit here. And then there's a drop here. And this drop is partly because their rate of growth during puberty is much slower than a reference population. And especially nowadays, because we know that puberty is happening younger and faster, particularly in girls in high income, and then there could be lots of reasons for that. Overnutrition is one of them, but hormones, all sorts of things. So you see this big drop here, but it's not entirely real because they're just doing it slower, and then they continue growth for longer, particularly in boys. So they actually back up to a bit above where they were here in terms of Z-score. So it's important to remember that boys in particular might grow slower, but will grow for longer. And one of the reasons why I always push that we should use the UK population reference data for older children is that the UK population data goes up to age 23. Because even in European populations, boys in particular do tend to grow a little bit up to older age. And girls too, but girls, there's more like 18, 19, most stop. So the point here is that we might be able to intervene here and push children to grow a little bit faster and maybe for longer. Because we don't want them to grow too fast because they might just put on fat, but we want them to try and catch up by growing for longer. This is a key paper, though, which was taking one hospital in rural Kenya where there's a population HDSS, health and demographic surveillance system. So they follow all the children in this area. And this was measuring the height for age, MIOAC, weight for age of all pediatric admissions. And the key thing from this to remember is that there's no sudden increase in mortality or admissions at -2. It's a sort of convenience cutoff. In that for wasting, we say this is when we should intervene with this child. But in these populations, that whole normal distribution is shifted. It's not like your population is oh, these are the children that are not growing properly, and these are the normal children. Instead, you have that normal distribution here instead of here. So, and you see the same thing. So here's your MUAC expressed as a Z-score for age. And then as it gets worse, there's this linear relationship between risk of admission and death for MUAC, and also for height for age, and weight for age, weight for height. So I'm not going to talk about treatment of malnutrition. Again, there's references. So then I just want to touch on obesity. So this is a map, global prevalence of obesity. And obviously the dark red is high prevalence, and it's where you'd expect. America, England is worse than the rest of Europe, Australia. But also look at these countries here that are red. And dark yellow, South Africa, all of China now, even the Australian side of New Guinea. So even in low and middle income countries, obesity is becoming a global health problem. And then I've talked about it already. Even in the same population, you can have over and under nutrition combined, and that's often from cheap calories, which are often processed foods that are low in micronutrients. And a good example, which I took this in the UK, but it's the same in many places, where in the UK with $50, I could buy this packet of these. They're like these cheap everyday biscuits or cookies. And if I ate the whole packet of biscuits, that would give me my day's energy requirement for 50 cents. If I wanted to buy my healthy energy and micronutrient requirements, it's going to cost me a lot more than 50 cents. So this is the same in high-income countries and increasingly in these low-income countries. And this is the best picture I could find, was a wedding celebration in Ghana. And you've got your mamas here, where again, it's good to be a big mama. And the tradition there is that as soon as your sons get married, the daughter-in-law comes and moves in, and then your job is done. You sit there and your daughter-in-law does all the cooking, the farming, the work, everything, and your job is now to eat. And so you have these very thin, slender young women who are working really hard, and the big mamas. So in the same household, you've got this. And if you go to the markets in Ghana or South Africa now, what do you see in the market that 30, 40 years ago you wouldn't see? Was the big plastic drums of oil, cheap oil. And oil is good. Fat, you need fat in your diet, but not too much, and not fried foods every day. So I have overrun, and we did have a little practical to do. So I want you to start having a look at it, and then maybe you can talk about it over lunch, and we can talk about it later.